Hello and welcome to Module 2 OSPF configuration. This is video 2, so don't forget to take your notes and upload them whenever we're ready, whenever we're done, of course. All right, so we're back to the multi-access network, right? We got all three routers connected to a switch, so let's get into that. And here are some more notes you need to do. All right, so how do you create a multi-access network? Let me just move this over so you'll see what I'm talking about while I'm pointing to it. Probably a good idea to do that. All right, so routers are connected to a layer 2 switch. All right, so you create a multi-access and you choose the Ethernet ports, no serial. This is probably a campus you can have. And this way, by the way, if you do this, you don't have to worry about STP and all of that wonderful stuff and all of that great, you could do it at layer 3, and routing protocols do a much better job than STP in terms of redundancies. All right, routers are going to elect a designated router and a backup designated router, just like we talked about that on the last video, and they're going to pick the ones with the highest priority number. If the priority number is the default one, then they're going to pick the one with the highest router ID, right? And how do you configure a router ID? You could do it using statically, router-ID, and you give it an IP address. In this case, 33333. This guy has 2222. This guy has 1111. If you don't do that, then routers are going to pick the highest configured loopback. If there is no loopback address configured, then the routers are going to pick their active interfaces, the highest. You have more than one active interface, you're going to pick the one with the highest. Okay? All right. So that's going to automatically happen. I just want to leave this over so you can see the notes, because I want you to write the notes. Okay, so there you go. All right, so to verify the router, it will show type IP OSPF interface. And that's going to display if you have the designated router, the backup, or if you are neither one of them. Right? It will also show you the priority number, the router ID number, by when you type that command. All right, to verify if you have a designated or a backup designated, you type show IP OSPF neighbor. Please write these commands down and keep them with you, so in case when you are working with OSPF, everything is right here, everything that you need. All right. Election of the designated router and the backup designated router. All right, so we talked about that, right? The guy with the highest priority wins. If not, the highest with the highest router ID wins. All right, how do you modify a priority number? You go to the interfaces, and then you type interface G00, assuming this is G00, and you type IP OSPF priority 255. All right, and when you're done, you clear the IP OSPF process here, and you clear it on all of them, by the way. You start clearing with the one where you put the highest priority number, and then when you type in this command, right here, show IPS OPS interface, and you can interface G00 at the end here, then you'll see that this guy became a designated router. All right, so single area. Now, what happens if you have routes? This is another router here, point to point, and another multi-access. You could do that. You can grow another, you have a lot of links. Let's say these links are not the same. This guy, these links may be different, and there's maybe another switch and another switch and another switch, and they are connected to each other, right? And all the routers connect to layer 2 switches. And so how do you find the best link to get to the destination that you need to? So the way it calculates is they calculate the cost. The cost is there's a reference bandwidth, which is 100 million bits per second, divided by whatever your interface is. So if your interface is 1 megabit per second, 100 megabits per second, so 100 million divided by 100, you'll get 1. If your interface right here is 10 megabits, so 100 divided by 10, and you'll get this, the cost will be 10, right? But as you can see, for gigabit Ethernet and 10 gigabit Ethernet, you got 100 divided by megabits, let's say it's 100, we'll get a 1. If it's gigabit, 100 divided by 1,000, you'll get 0.1, and that will be rounded up to 1. 10 gigabit, again, will be rounded up to 1. So having 100 megabits, a gigabit, or a 10 gigabit, they will have the same cost. So if you know that what you're going to do is you want to change the reference bandwidth to match the highest bandwidth on all the interfaces. So if you have 10 gigabit is the highest, so you make the reference bandwidth 10 gigabits on all the routers. And this way, the 10 gigabit will have a cost of 1 and the others will be in multiples of 10. And therefore, the gigabit will be the best route. Is that clear? All right, so how do you modify the reference bandwidth? You just type in the command autocost reference bandwidth and you type it in megabits per second. So if you have if you have a gigabit, you just type 1,000. Or you can modify the cost directly. You don't even have to do bandwidth and have it calculate the cost. You just type IP OSPF cost on the interface and you're all good to go. All right, so the cost is the accumulated value from the source to the destination, all the way to the destination. All right, so that would be your cost. If you think about it, it's really all the best highway speed to the destination. They don't care about if there's traffic on those links. They figured the fastest interface, the status of the links, that's why we call it link status. If the status of the link, which is the bandwidth, is very high, like 10 gigabit, that means it's a good interface to go through, which means it's quicker. It's like having a highway speed of 75 and another route that has a highway speed limit of 25. You would take the ones with the 75 megabits per second, right? Because that's a faster highway, even though there might be traffic and you're not moving. That's what OSPF will pick. EIGRP, by the way, looks for the fastest route, but also looks at if there's traffic. But we're not discussing OSPF here. All right, another thing that we need to worry about is the hello and dead intervals on the routers. Okay, if you remember when we talked about that last week on this video, the hello is every 10 seconds by default, they say hello to each other. Oh, you don't have to respond back, you just have to say hello. And for example, router 1 saying hello to router 2 every 10 seconds by default. And he says, okay, he's my neighbor. And router 2 is expecting to hear from him every 10 seconds. If he doesn't hear from him after 4 times the hello interval, let's say after 40 seconds, then router 2 will say, okay, router 1 is out, dead. So they both have to agree on the hello and the dead intervals. Otherwise, they will not be neighbors, even though they're in the same area. All right. And sometimes you want to reduce it from 10 to, let's say, 5 seconds. Say hello every 5 seconds. Why? Because if a thing went down, your interface went down, you want the dead time interval to be 4 times 5 is in 20 seconds, he'll know that this is dead instead of 40 seconds. So you want to speed up the update, right? Sometimes you want to do that, but you got to be careful. If you do it to these routers, you got to do it to everybody. Everyone has to have the same hello and dead interval. And to do that, you go to the interface and you type OSPF hello 5 instead of 10. You reduced it. And dead interval 20 instead of 40. Okay? And to check on them, you can go up here and type, where's the command? There's a command that I gave you. I'll give you down here to find out what your hello intervals, if you wanted to. And look for that on a CCNA test, by the way. You can have all the configuration correct, but if one of the routers they left with different hello intervals and dead intervals than the others, they will not participate in OSPF. And that is why you would say that OSPF doesn't have anything in the routing table, is because you checked and you saw that the hello interval and the dead interval is different than all the others, even though its configuration is correctly. All right, so let's say this router, the master router, is connected to the internet, right? And he creates an, let's say, assuming that I wrote down, I did a default route on router 2 or on router 1, let's say, just because I have it. I said, I'm assuming that the loopback 1 has been created and we're simulating the loopback 1 interface, which is a virtual interface. It's like an ISP. So any packet that is not going to match is going to be sent to the internet, loopback 1. If I want everybody to send their packets to me, set their default routes to me, instead of having everybody connected to the internet, so what I do is I'll say, hey, router OSPF number 10 from the config mode, default information originate. This command, default dash information originate, will be sent by router 1 to all OSPF in the area, all his neighbors, telling them to set their routing, their default routes, set it to me. So if nobody matches any of the packet on router 2 or router 3 routing table, they're going to send the packet to me. And then when they send it to me, of course, I am connected to the internet. So default information originate is when you default route propagation to all the other routers. All right, so please, you're writing all of this down, okay? Now, let's look at some commands. Show IP OSPF neighbor. That's going to verify the router has formed adjacencies, right? If you want to make sure if we have neighbors. If you don't see your neighbor, check out the hello intervals. That could be a cause of the problem, right? If you type show IP protocols, okay, this is going to include the OSPF process ID, router ID. It will show interfaces that are explicitly configured to advertise OSPF, the neighbors, right? The default administrative distance will show up as 110. All right, show IP OSPF if you want to examine the process ID and the router ID and area information. Show IP OSPF interface, G00. This is going to give you all the goodies. This is a good command to play around with. She's going to show the process ID, the router ID, the type of network, or the cost, if you are a designated or a backup designated router, if you are, of course, on a multi-access network like this one. And if you type show IP OSPF interface brief, this is going to give you a summary of everything else. All right, so this is all I want you to write down. Now, what I want to do is we actually went over all the slides. So I am going to show you that we actually did all of this. All right, so when you're finished writing this up, just pay attention in here and we'll go over, you'll take a look at what these output of the commands. So for example, show IP OSPF gigabit 00. So this guy is a DR others. He has a priority of 1. His router ID is this, and he's the backup router ID, right? A lot of good stuff in here. The IP address, and it's up physically and up protocol configuration wise. All right. If you type show OSPF in this interface, this is the backup designated router, right? This is the designated router, has a priority of 1, but his router ID is the highest, right? To verify his show IP OSPF neighbor. His neighbors are 111-3333, right? Because he's 222. His neighbor is a DR others, and his number 3 is the designated router. Most likely, if there's only 3 routers, he is probably the backup designated router. His neighbor, next hop address is the 192.168.1.1, right? And his neighbor is 1.3. Okay. What else? We talked about that. When somebody comes back, he's already in there. OS priority number. This is how you type it. We did that. You go to the interface to do that. The bandwidth, the reference bandwidth divided by the actual interface to calculate the cost. You see, the 10 gigabit, the 1 gigabit, the 100 are referenced to one. You have to change them. All right, so that's it for this chapter. So please submit everything I asked you to. And when you're all done, I'll see you on the next video.